Hey, this is a quick video about electrical troubleshooting, and we are going to be using this circuit for our explanation of why we would read certain things on our test points with a voltmeter. When I say test points, I mean terminal block points, and we have terminal block 1, 2, 3, and 4, and along with our main buses, positive and negative main bus. These numbers represent contacts associated with this relay, control relay 1. If these were normally closed, they would be underlined, but they're both normally open. So if we go to rung 1, these are your rung numbers. We see that this is a normally open CR11 from this relay, and this one's normally open. So that's what these two numbers represent. Control relay 2 has a contact in rung 2 right here and in rung 3. You have two push buttons, and these push buttons are controlling each of these relays. I do realize that those of you that are familiar with this type of control, if you push both buttons at the same time, we have a short circuit, but we're not going to do that in this example. So here is power applied to the circuit. Everything is fine. Red represents positive, black is negative, and orange is neutral, which is neither positive or negative. Now I push PB1, energizing control relay 1, and all the contacts associated with CR1 change state. If they were normally closed, they would open, and because they were normally open, they closed. So while I'm holding this button in, I'm setting power positive to terminal block 3 all the way to the relay to energize it. And these two contacts closed, sending positive on this side of the motor and negative to this side of the motor. Notice negative does make it all the way down to here and it stops. And same thing here, positive makes it to this point and stops because CR2 is not being energized. Now let's talk about voltage points. If I took a meter from the positive bus to 1, that would read 0 volts because look, they are both positive. 2 to negative would be 0 volts. But negative to 1, I would see the supply voltage. Positive to 2, I would see the supply voltage. Notice the color difference. Positive to 3, supply voltage. I'm sorry, 0. That would be 0 because they are the same color. I was jumping ahead. My next statement is positive to 4. Supply voltage. Now, the negative is traveling through this coil of wire. This is nothing but a coil of wire in this relay all the way to point 4. Even though push button 2 is not being touched, that's why I'm seeing from the positive bus to 4, I'm seeing the supply voltage. Now I'm pushing PB2 to energize CR2. Notice that the positive now travels to terminal block 4. If I took that same reading from the positive bus to 4, now I would read 0, which would be telling me I have a good push button. Alright, so CR2 contacts close, and now we've reversed the polarity of the motor. I'll go back to the previous slide. Pay attention to points 1 and 2. There's one polarity, and now we flip the polarity to change the direction of the motor. So our negative is being sent to 1, and our positive is being sent to point 2. Now we have a failure. Control relay 1 has failed, burned open, and we are not touching any buttons. Well, notice that point 3 is now neutral. So if I went from 4 to 3, I would read 0 volts. And that's without pushing any buttons. I'm not pushing PB2 and I go from positive bus to 4, I'd read voltage because the negative traveling through this coil of wire makes it to here. So if I read 4 to 3 and I see 0, I can feel pretty confident my problem is the control relay coil. Now if I push PB1, trying to make it energize, and nothing is happening in the circuit, and I take a reading from 4 to 3, it's still going to read 0 as it's supposed to. If I go from 3 to negative, it's still going to see supply voltage like it's supposed to. The only way I'll know for sure is to not push the button and take that reading from 4 to 3. Same thing with a control relay 2 failure. Here I am pushing the button, nothing's happening. And if I took a reading at my motor, I would verify that no power is being sent to the motor. If I let go of the button, then I could take a reading from positive to 4 and see that there is no voltage. Now here we are with a failed motor. I'm pushing PB1 in, I'm energizing this relay, CR1 contacts have closed. The only way for me to verify that this relay is doing what it should and both these contacts are fine is to take the reading right at 1 and 2. And as you can see, I would see supply voltage. Now here's a contact failure from one of the relays, CR1. I'm pushing PB1 in. This relay is energizing like it should. Notice that I could verify with a reading from 4 to 3. If I saw 0 volts, I know that's happening. But my motor is not moving. Well, if I take my voltmeter from 1 to 2 this time, I'm going to see 0 volts. It's all negative. Pay attention to the contacts. Yeah, this is sending negative to here, and it's going through this good motor to here, all the way to here. Then down to this point, and it stops. This point was already connected to the negative bus. And because 2 is negative, it would make it down to here. Here's another contact failure. Again, 0 volts at the motor. And another one. And another one. Each one of these, I could read voltage drops across my relays, verifying that my coil is getting power. But going up here, I'm seeing that no power would be getting to my motor. Now here's a push button failure. PB1's failed and I'm pushing it in. Well, if everything was good, I would be reading 0 volts from positive bus to 4. But here I am pushing that button and I'm seeing voltage. I'm seeing supply voltage. So this is good, sending negative all the way to here, and this button has failed. And you would be able to do the same thing at this push button.